the European Train Control System is a signaling, control and train protection system designed to replace the many incompatible safety systems currently used by European railways, especially on high-speed lines. ETCS requires standard trackside equipment and a standard controller within the train cab. In its final form, all lineside information is passed to the driver electronically, removing the need for lineside signals which, at high speed, could be almost impossible to see or assimilate. The need for ETCS stems from EU Directive 96/48 about the interoperability of high-speed trains, followed by Directive 2001/16 extending the concept of interoperability to the conventional rail system. ETCS specifications have become part, or are referred to, the Technical Specification for Interoperability for Control Command Systems, which is a piece of European legislation managed by the European Railway Agency. It is a legal requirement that all new, upgraded or renewed tracks and rolling stock in the European railway system should adopt ETCS, possibly keeping legacy systems for backward compatibility. Many networks outside the EU have also adopted ETCS, generally for high-speed rail projects. ETCS is specified at 4 different levels. Level 0, ETCS-compliant locomotives or rolling stock interact with lineside equipment that is non-ETCS compliant. Level 1, ETCS is installed on lineside and on board. Spot transmission of data from track to train via ETCS balizers. Level 2, as Level 1, but ETCS data transmission is continuous. The currently used data carrier is GSMR. Level 3, as Level 2, but train location and train integrity supervision no longer rely on trackside equipment such as track circuits or axle counters. History: the European railway network grew from separate national networks with little more in common than standard gauge. Notable differences include voltages, loading gauge, couplings, signaling and control systems. By the end of the 1980s there were 14 national standard train control systems in use across the EU, and the advent of high-speed trains showed that signaling based on lineside signals is insufficient. Both factors led to efforts to reduce the time and cost of cross-border traffic. On 4 and 5 December 1989, a working group including transport ministers resolved a master plan for a trans-European high-speed rail network, the first time that ETCS was suggested. The Commission communicated the decision to the European Council, which approved the plan in its resolution of December 17, 1990. This led to a resolution on 91 EEC as of July 29, 1991, which mandated the creation of a requirements list for interoperability in high-speed rail transport. The rail manufacturing industry and rail network operators had agreed on creation of interoperability standards in June 1991. Until 1993 the organizational framework was created to start technical specifications that would be published as TSI standards. The mandate for TSI was resolved by 93 EEC. In 1995 a development plan first mentioned the creation of the European Rail Traffic Management System. The specification was written in 1996 in response to EU Council Directive 96/EC 99 of July 23, 1996 on interoperability of the Trans-European High-Speed Rail System. First the European Railway Research Institute was instructed to formulate the specification, and about the same time the ERTMS user group was formed from 6 railway operators that took over the lead role in the specification. The standardization went on for the next 2 years and it was felt to be slow for some industry partners. Euro 1998 saw the formation of Unizig, including Alstom, Ansaldo, Bombardier, Invens, Siemens and Thales, which were to take over the finalization of the standard. In July 1998 SRS-5 documents were published that formed the baseline for technical specifications. Unizig provided for corrections and enhancements of the baseline specification leading to the Class P specification in April 1999. The baseline specification has been tested by 6 railways since 1999 as part of the European Rail Traffic Management System. The railway companies defined some extended requirements that were included to ETCS, leading to the Class 1 version 2.0.0 specification of ETCS that was published in April 2000. Further specification continued through a number of drafts until UNISEAC published the subset 026 defining the current implementation of ETCS signalling equipment to Euro. This Class 1 version 2.2.2 was accepted by the European Commission in Decision 2002 EEC as mandatory for high-speed rail and in Decision 2004 EEC as mandatory for conventional rail. The subset 026 is defined from 8 chapters, where Chapter 7 defines the ETCS language and Chapter 8 describes the Bely's telegram structure of ETCS Level 1. Later UNISEAC published the corrections as subset 108, also known as Class 1 version 2.2.2 plus, that was accepted in Decision 2006 EEC. The earlier ETCS specification contained a lot of optional elements that limited interoperability. The Class 1 specifications were revised in the following year, leading to version 2.3.0 document series that was made mandatory by the European Commission in Decision 2007 EEC on March 9, 2007. Annex A describes the technical specifications on interoperability for high-speed and conventional rail transport. Using version 2.3.0, a number of railway operators started to deploy ETCS on a large scale. For example, the Italian Sistema Controllo Marcia Trino is based on Level 1 Bely's. Further development concentrated on compatibility specification with the earlier Class B systems, leading to specifications like Eurosub that continued to use the national rail management on top of Eurobely's for a transitional period. Following the experience in railway operation, the ERA published a revised specification Class 1 version 2.3.0D that was accepted by the European Commission in July 2008. The final ETCS is divided into 9 equipment and functional levels. The definition of the level depends on how the route is equipped and the way in which information is transmitted to the train. The movement authority and the corresponding route information are transmitted to the train and displayed in the cab. A vehicle fitted with complete ERTMS ETCS equipment and functionality can operate on any ETCS route without any technical restrictions. While some countries switched to ETCS, German and French railway operators had already introduced a modern type of train control system, so they would gain no benefit. Instead, ideas were introduced on new modes like limited supervision that would allow for a low-cost variant, a new and superior model for braking curves, a cold movement optimization and additional track description options. These ideas were compiled into a baseline 3 series by the ERA, published as a Class 1 version 3.0.0 proposal on December 23, 2008. The first consolidation of the baseline 3 proposal was published by ERA on February 26, 2010, and the second consolidation on January 11, 2011. The specification GSM Baseline 0 was published as Annex A to the Baseline 3 proposal on April 17, 2012. At the same time, a change to Annex A of Baseline 2 was proposed to the European Commission that includes GSM Baseline 0, allowing ETCS 3.3.0 trains to run on ETCS 2.3.0D tracks. The Baseline 3 proposal was accepted by the European Commission with Decision 2012 EU on January 25, 2012, and the update for ETCS 3.3.0 and the extension for ETCS 2.3.0D were accepted by the European Commission with Decision 2012 EU on November 6, 2012. The ERA work program concentrates on the refinement of the test specification SRS 3.3.0 to be published in July 2013. In parallel, the GSM specification will be extended into a GSM Baseline 1 until the end of 2013. The German Deutsche Bahn has since announced equipping at least the 10 corridors running on older tracks to be using either Level 1 limited supervision or Level 2 on high-speed sections. Current work continues on Level 3 definition with low-cost specifications and the integration of GPRS into the radio protocol to increase the signaling bandwidth as required in shunting stations. The specifications number 2 were published as recommendations SRS 3.4.0 and ETCS 3.4.0 by the ERA in May 2014 to be submitted for the opinion of the Railway Interoperability and Safety Committee in the meeting N. 70 in June 2014. Stakeholders such as Deutsche Bahn have opted for a streamlined development model for ETCS. DB will assemble a database of change requests to be assembled by priority and effect in a CR list for the next milestone report that shall be published on fixed dates through ERA. The SRS 3.4.0 from Q2 2014 matches with the first MR1 from this process. The further steps are planned for the MR2 to be published in Q4 2015 and the MR3 to be published in Q3 2017. Each specification will be commented on and handed over to the risk for subsequent legalization in the European Union. Deployment planning. The development of ETCS has matured to a point that cross-border traffic is possible and some countries have announced a date for the end of older systems. The first contract to run the full length of a cross-border railway was signed by Germany and France in 2004 on the high-speed line from Paris to Frankfurt, including LGV Estate. The connection opened in 2007 using ICE3MF, to be operational with ERTMS trains by 2016. The Netherlands, Germany, Switzerland and Italy have a commitment to open Corridor 8 from Rotterdam to Genoa for freight by the start of 2015. Switzerland has announced in 2011 that it will switch from its national ZUB signum to ETCS Level 1 for conventional rail by enabling L1LS packets on its transitional Euro ZUB balizes during 2017. France will replace KVB on high-speed lines by 2017 with Level 2. Germany will start replacing all its PZB and LZB systems in 2015, to be finished by 2027. Deutsche Bahn has expressed a commitment to keep the baseline 3 specification backward compatible starting at least with SRS 3.5.0 which is due in 2015 according to the streamlined MR2 process, with the first MR1 adding requirements from its tests in preparation for the switch to ETCS. Denmark has decided to drop its older ATC, which will reach its end of life between 2015 and 2020, switching the network of 2100 km to ETCS. The S-Bahn network in Copenhagen will use the Siemens train guard system. 2 suppliers will equip the rest of the country to Level 2 with an option for Level 3 in rural parts. Implementation will be between 2014 and 2018. Non-European countries are starting to deploy ERTMS ETCS, including Algeria, China, India, Kazakhstan, Korea, Libya, Mexico, New Zealand and Saudi Arabia. Australia will switch to ETCS on some dedicated lines starting in 2013. Levels of ETCS. Level 0. Level 0 applies when an ETCS-fitted vehicle is used on a non-ETCS route. The trainban equipment monitors the maximum speed of that type of train. The train driver observes the trackside signals. Since signals can have different meanings on different railways, this level restricts drivers to one railway. If the train has left a higher level ETCS, it might be limited in speed globally by the last balizes encountered. Level 1. Level 1 is a cab signaling system that can be superimposed on the existing signaling system, leaving the fixed signal system in place. Eurobalize radio beacons pick up signal aspects from the trackside signals via signal adapters and telegram coders and transmit them to the vehicle as a movement authority together with route data at fixed points. The onboard computer continuously monitors and calculates the maximum speed and the braking curve from this data. Because of the spot transmission of data, the train must travel over the Eurobalize beacon to obtain the next movement authority. With the installation of additional Eurobalizes or a Gyro Loop between the distant signal and main signal, the new proceed aspect is transmitted continuously. The Gyro Loop is an extension of the Eurobalize over a particular distance which basically allows data to be transmitted continuously to the vehicle over cables emitting electromagnetic waves. A radio version of the Gyro Loop is also possible. For example, in Denmark and Sweden the meanings of single green and double green are contradictory. Since Level 1 knows the difference, drivers can drive beyond the national borders safely. Deployment. Croatian railways are installing Level 1 on the Vinkovci-Eurotovarnik line. In Hungary, the Budapest-Euro-Hegyi-Salomons-Laksa copyright bar Euro-Hectocube DOS lines are equipped with Level 1. In Poland, Level 1 was installed in 2011 in the CMK high-speed line between Warsaw and Katowice-Kraków W, to allow speeds to be raised from 160 km/h to 200 km/h, and eventually to 250 km/h. The CMK line, which was built in the 1970s, was designed for a top speed of 250 km/h but was not operated above 160 km/h due to lack of cab signaling. The ETCS signaling on the CMK was certified on November 21, 2013, allowing trains on the CMK to operate at 200 km/h. In Slovakia, the system has been deployed as part of the Bratislava-Eurokoice mainline modernization program, currently between Bratislava and Nova Copyright Mesto nad Váhom, with the rest of the line to follow. The current implementation is limited to 160 km/h due to limited braking distances between the control segments. In northeast China, Level 1 is deployed on the Beijing-Euro-Tianjin intercity rail line. In Auckland, New Zealand, the first true ETCS Level 1 system in the Southern Hemisphere was commissioned on April 29, 2014 for Kiwi Rail by Siemens Rail Automation, in conjunction with the introduction of the ETCS-compliant AM-class electric multiple units. Implementation in Adelaide, SA is planned for mid-late 2014. Limited supervision mode allows the ETCS cab computer to disregard some information in comparison to the traditional full supervision mode. Formally this is possible for all ETCS levels but it is most commonly used with Level 1 Euro. Specifically, the ETCS equipment is only used to control the safety restrictions while the communication of a movement authority is left to other systems. This allows older tracks to be rebuilt by adding ETCS L1LS equipment where movement authority is derived from the existing line-side equipment or radioed by GSMR. Studies have shown that ETCS L1LS has the same capacity as plain Level 1 for half the cost, which has led to railway operators pushing for the inclusion of limited supervision into the ETCS standard. However, this had been delayed until the successor version 3.0.0 Plus of ETCS, which is planned to be available as a legal foundation not earlier than 2012. Limited supervision mode was proposed by RFF-SNCF based on a proposal by SBB. Several years later a steering group was announced in spring 2004. After the UIC workshop on June 30, 2004, it was agreed that UIC should produce a FRS document as the first step. The resulting proposal was distributed to the 8 administrations that were identified: ABB, SNCB NMBS, BDK, DB, RFI, CFR, Network Rail and SBB. After 2004, German Deutsche Bahn took over the responsibility for the change request. In Switzerland, the Ministry of Transport BAV announced in August 2011 that beginning with 2018 the Eurobalize-based Eurosar Bureau Signum signaling will be switched to Level 1 limited supervision. The North-South corridor will be switched to ETCS by 2015 according to international contracts regarding the 10T Corridor A from Rotterdam to Genoa. Level 2. Level 2 is a digital radio-based system. Movement authority and other signal aspects are displayed in the cab for the driver. Apart from a few indicator panels, it is therefore possible to dispense with trackside signaling. However, the track release signaling and hence the train integrity supervision still remain in place at the trackside. All trains automatically report their exact position and direction of travel to the radio block center at regular intervals. Train movements are monitored continually by the radio block center. The movement authority is transmitted to the vehicle continuously via GSMR together with speed information and route data. The Eurobalizers are used at this level as passive positioning beacons or electronic milestones. Between two positioning beacons, the train determines its position via sensors. The positioning beacons are used in this case as reference points for correcting distance measurement errors. The onboard computer continuously monitors the transferred data and the maximum permissible speed. Deployment. In July 2009 the European Commission announced that ETCS is mandatory for all EU-funded projects that include new or upgraded signaling, and GSMR is required when radio communications are upgraded. Level 2 installations in Switzerland, Italy, the Netherlands, Germany, France, Sweden, and Belgium are operational. In Switzerland, ETCS Level 2 is installed on the Mattstetten-Rothreis new line, a high-speed line opened in 2004 between Bern and Zurich for train speeds of 200 km/h, whose ETCS Level 2 installation was the pioneering ETCS installation in Switzerland. Technical problems with the new ETCS technology caused ETCS operation to be put off past the planned starting date of December 2004, and ETCS Level 2 operation was fully implemented in March 2007. In Denmark, plans were announced in December 2008 for the conversion of its entire national network to Level 2. This was necessitated by the near-obsolete nature of parts of its network. The total cost of the project is estimated at 3.3 billion, with conversion beginning in 2009 and projected for completion in 2021. In Italy, Level 2 is used on the Roma-Naples high-speed line opened in December 2005. In Spain, Level 2 was commissioned on the Madrid-Barcelona high-speed rail line in October 2011, allowing the speed to be raised to 310 km/h with Madrid-Barcelona travel times reduced to 2 hours 30 minutes. In Sweden, the Bothnia line was inaugurated in August 2010 using Level 2. In Hungary Level 2 is under construction in the Kenfar paragraph LD SAR copyright XVH copyright RVA line as a part of a full reconstruction, and planned to be ready before 2015. In Poland, Level 2 is being installed as part of a major upgrading of the 346 km Warsaw Gdańsk Gdynia line, which will reduce travel times from 6 hours to about 2–1/2 hours. The Level 2 installation is to be completed by June 2015. In Poland, Level 2 is being installed on the Warsaw-Angstroma-Kubda line. In Poland, Level 2 has been installed on line E30 between Legnica a Euro-1 registered trademark Linica Euro-Biała Dolna on the German border. In Turkey, Level 2 is installed on the Ankara-Euro-Konya high-speed line designed for 250 km/h. The high-speed line has reduced Ankara-Konya travel times from January 2 10 hours to 75 minutes. In China, Level 2 is deployed on the 1000 km Wuhan-Euro-Guangzhou high-speed railway. In Wales, Level 2 began to be used by passenger trains on the Cambrian line in October 2010. This is a trial before wider deployment across Great Britain. In 2013, a Network Rail Class 97/3 locomotive with Hitachi's Level 2 onboard equipment successfully completed demonstration tests. In Libya, Ansaldo Streets was awarded a contract in July 2009 to install Level 2. Level 3. With Level 3, ETCS goes beyond pure train protection functionality with the implementation of full radio-based train spacing. Fixed track release signaling devices are no longer required. As with Level 2, trains find their position themselves by means of positioning beacons and via sensors, and must also be capable of determining train integrity on board to the very highest degree of reliability. By transmitting the positioning signal to the radio block center, it is always possible to determine which point on the route the train has safely cleared. The following train can already be granted another movement authority up to this point. The route is thus no longer cleared in fixed track sections. In this respect, Level 3 departs from classic operation with fixed intervals. Given sufficiently short positioning intervals, continuous line clear authorization is achieved and train headways come close to the principle of operation with absolute braking distance spacing. Level 3 is currently under development. Solutions for reliable train integrity supervision are highly complex and are hardly suitable for transfer to older models of freight rolling stock. ERTMS Regional, a variant of Level 3 is ERTMS Regional, which has the option to be used with virtual fixed blocks or with true moving block signaling. It is possible to use train integrity supervision, or by accepting limited speed and traffic volume to lessen the effect and probability of colliding with dropped rail cars. ERTMS Regional has lower commissioning and maintenance costs since track release signaling devices are not routinely used, and is suitable for lines with low traffic volume. These low-density lines usually have no automatic train protection system today, and thus will benefit from the added safety. As a pilot, the railway between Malung and Borne Currency NGE in Sweden is operating with ERTMS Regional, in full operation from February 2012. In November 2010 demonstration runs were started using ERTMS Regional, attended by foreign visitors, for example from Network Rail. GNSS2, instead of using fixed data balizes to detect train location, there may be virtual balizes based on satellite navigation and differential GPS as it was researched by the UIC and ESA. The introduction depends on the future functionality of the EGNOS-supported Galileo satellite system. Experiences in the Locapril project show that real balizes are still required in railway stations. The successful usage of satellite navigation in the GLONASS-based Russian ABTCM block control has triggered the creation of the ATARIS ATC system that integrates Level 2 ABC elements. The manufacturers Ansaldo Streets and GNIAS aim for certification of the ETCS compatibility of this system. Ansaldo Streets has come to lead the UNISIAG work group on GNSS integration into ERTMS. There is a pilot project ERSAT running since 2013 on 50 km of track of the Cagliari Golfo Aranci Marittima Railway on Sardinia. The proposed Shifter-Squared Rail project will integrate Galileo satellites as soon as they come operational in 2014/2015 to test the EGNOS services, providing virtual basals that meet SIL4 safety of life criteria. Train-borne equipment EVC and STM, European trains will be fitted with an ERTMS on-board system composed of a computer and its peripheries, as the ERTMS system is deployed on rail networks throughout Europe. At this moment only certain corridors have been fitted for ERTMS. Trains running on these lines must therefore be equipped to run on both ERTMS lines and classic lines, which still rely on national systems. Such a dual system is called a Eurocab. A STM is a key element within the Eurocab. The STM handles the national Class B automatic train protection systems like PZB, MEMA, ATB. Locomotive operation modes in ETCS, full supervision, front a Euro. The locomotive pulls the train, ETCS has all required information, propelling a Euro. The locomotive pushes the train, ETCS must be aware that the front portion of the train will enter the block before the locomotive, partial supervision, unfitted a Euro. The line is not fitted with ETCS, the system will only observe master speed limit and train protection is left to older systems, post-trip a Euro. The train overpass the order to stop, full braking will be executed, on-site a Euro. On-site ride, staff responsible a Euro. The driver was granted permission to pass faulty signals, banking a Euro. The engine is helping a train by pushing it, lost a Euro. Lack of information from track-borne ETCS equipment, multiworking, non-leading a Euro. Second locomotive with its own driver, sleeping a Euro. Second locomotive controlled from the leading one, rear integrity a Euro. A locomotive at the train's rear controls its integrity, transport a Euro. Dead locomotive being transported, shunting a Euro. Shunting or maneuvering, on-off modes, start up a Euro. Power up self-test, data entry a Euro. Driver enters data regarding the train, power off a Euro. Shutdown, failures, system failure a Euro. Train ban ETCS equipment detected its failure, system isolation a Euro. Driver disconnected ETCS test laboratories. 3 ETCS test laboratories work together to bring support to the industry. Multitle has become accredited ISO 17025 for EVC tests since February 22, 2011. To be a reference laboratory, ERA is requesting the laboratories to be accredited ISO 17025. ETCS corridors, based on the proposal for 3010T priority axes and projects during 2003, a cost-benefit analysis was performed by the International Union of Railways, presented in December 2003. This identified 10 rail corridors covering about 20% of the 10 network that should be given priority in changing to ETCS, and these were included in Decision 884/EC by the European Commission. In 2005 the UIC combined the axes into the following ERTMS-ETCS corridors, subject to international development contracts: Corridor A, Rotterdam Duisburg Basel Genoa, Corridor B, Naples Bologna Innsbruck Munich Berlin Stockholm, Corridor C, Antwerp Strasbourg Basel Antwerp Dijon Lyon, Corridor D, Valencia Barcelona Lyon Turin Milan Trieste Ljubljana Budapest, Corridor E, Dresden Prague Vienna Budapest Constanta, Corridor F, Aachen Duisburg Hanover Magdeburg Berlin Potsdam Warsaw Belarus. The Trans-European Transport Network Executive Agency publishes ERTMS funding announcements showing the progress of trackside equipment and board equipment installation. Corridor A gets trackside equipment January 2007 December 2012, June 2008, December 2013. The B2 route in the Netherlands is already using Level 2 and Switzerland will switch to ETCS in 2015. Corridor B, January 2007 December 2012, January 2009, December 2013. Corridor C, May 2006 December 2009. Corridor D, January 2009 December 2013. Corridor E, June 2008 December 2012, May 2009, December 2013. Corridor F, January 2007 December 2012. Corridor A has two routes in Germany the double track east of the Rhine will be ready with ETCS in 2015, while the upgrade of the double track west of the Rhine will be postponed. Corridor F will be developed in accordance with Poland as far as it offers ETCS transport. Frankfurt Berlin Magdeburg will be ready in 2012. Hanover to Magdeburg Wittenberg Gar paragraph RLITZ in 2015. At the other end Aachen to Oberhausen will be ready in 2012, the missing section from Oberhausen to Hanover in 2020. The other two corridors are postponed and Germany chooses to support the equipment of locomotives with STMs to fulfill the requirement of ETCS transport on the corridors. See also, automatic train protection, communications-based train control, interoperable communications-based signalling, metrication of British transport, train protection system, references. External links, Commission facilitates interoperability for Europe's trains, ETCS homepage of the UIC, BNET United Kingdom, can ERTMS ETCS become ERTMS UTCS?